Hello everyone, and welcome to this new section in which we'll delve deep into implementing data augmentation with TensorFlow 2. The first method we'll use in implementing data augmentation will be using this TensorFlow image model, which is made of these different functions. Now, this is just a few of these functions, and you could check out the rest in the documentation. So we'll be able to do stuff like adjusting brightness, contrast, gamma adjustments, saturation adjustment, flipping left right, flipping up down, and rotation. Using this Tf.image is known to be a more flexible way of implementing data augmentation, as we could alter an input image with all these different functions given to us. The next method we'll use or we'll implement in this course is by working with the keras.layers. And although we're limited by the number of data augmentation layers made available to us, this method permits us to carry out data augmentation more efficiently and hence speeds up the training process. Now, to find a balance between these two methods, we could implement our own custom keras.layers. And that's exactly what we're gonna do in this section. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. We'll now look at how to implement data augmentation with TensorFlow. So we're going to get into TensorFlow.images. So here we have TF, here is layers, we actually in keras, closes up, and tf.image actually. So we have this tf.image with all these methods which we could use in data augmentation. Recall that in order to do data augmentation, we're basically modifying the images while keeping the labels fixed. So that said, as you could see here, we have this several methods. Let's check out on this overview, and we should be able to get this list of methods. So here we have the list of methods, and we have the categories. So here we have image adjustments, working with bounding boxes. Here is for object detection, we're here to get into this. Here is cropping, flipping, and decoding and encoding. So this is what we have. Now, if we get back to the top, we'll have this adjustments. Okay, so we have this resize, which we've seen already. And then we have this adjustments. We could adjust the brightness, contrast, gamma, hue, JPEG quality, saturation, brightness, contrast, hue, saturation, and per image standardization. Now notice that these ones here are random, so we are adjusting our image randomly. As you can see, we have random brightness, whereas here we actually adjusting this brightness with some fixed parameters. So if we click on this adjust brightness right here, you see we have this image and we have this fixed delta which we choose. Whereas if it's random, let's get back, if it's random, that will be fixed randomly. So if we click on this random brightness, you see we are just given a max delta because we just all we need to pass in here is a range, and then we are going to randomly pick a delta in that range. So that's it for this image adjustments. We also have this cropping, so we could crop out some parts of the image. We could crop or do a central crop. We could crop and resize. So this means if we have this image, so we have this image and it's 224 by 224, and then we want to do a crop. We could do a center crop like this. We could take this center crop. Sorry for that. We have this center crop, and we have this new image right here, which is this center. Now, after getting this image, let's suppose we have now this smaller image of shape, say 150 by 150. And then what we could do now is to resize this so that we get this shape which we need to pass into the model. So we could resize this, hence the reason why we're using the crop by resize, crop and resize right here. And you could as well just crop and then do the resize manually. So that's it. We have flipping, rotating. So flipping, We have an image, we flip it left, right, up, down, randomly. So it's basically the same thing, but this time around we're doing it randomly. Rotation, and then the transposition of the image. So as you could see, TensorFlow gives us all these methods which we could use in modifying our images and hence augmenting our data. So here we will define this method visualize, so you could see this clearly. We have the original image and then we have the augmented image. Now in here we have subplot. We want just one line, 2 columns, and this will occupy the first position in that 2 column space. So here now we have this im show, which takes in the original, and then we repeat this. So here we have this second position, and then we have the augmented. Okay, so that's our visualize method. Now what we'll do is we are going to get the original image. So let's say we have this original image, which is equal an element which we take from our data set. So we have train data set, and then let's just pick one element. So we have this, and then we take just one element from our data set. Now that's it, and this should output the label. So we should have the label, and there we go. So we have the original image here, and then we now work with the augmented image. We get this augmented image, and to obtain this augmented image, we are going to modify this original image. To do this modification, we are going to make use of these methods which we've seen already. So here, let's pick out this flip left right. We click on this flip left right and see what we get. So all we need to do here is just to pass the image. So let's copy this, and then what we have here is our flip left right and our image which has been passed. That's fine. We have original image. So that's it. Now we have this augmented image. We could run that, and then we could go ahead and visualize this augmentation. So here we have original image and augmented image. Okay, so we run this and see what we get. So that's it. You see that now in your data or in your data set, you will not only get this image right here, you will not only get this one, but you would get this and this. So this means our data set now will be multiplied by 2. Let's check on other augmentation strategies. Let's get back. Here we go. We have flip up down. This similar to what we've seen already. Okay, let's check out. Let's do this random flip up down, and then let's click on this and then rotation by 90 degrees. So here we have this image similar, and then they could specify the seed. So here we have the random flip up down. Let's run that, and then here we have random flip up down. Okay, so we run that again. We have our augmented image, and then we visualize. You see that it happens that it's exactly the same image which is outputted. Well, let's run this again, and now what we get is instead this. So notice how there's a difference between these 2 images. So that's it. The next will be this rot 90 degrees. You could click on that. You could always feel free to click and then understand what it actually means. Like here we're told is rotate image counterclockwise by 90 degrees. Now let's take this off. We know clockwise is this direction. So rotating counterclockwise means we'll be rotating it in this direction by 90 degrees. So that's it. Let's take this off, and then we have rot 90. We run that, and there we go. Okay, so as you can see, we've rotated this by 90 degrees in the anti-clockwise direction. We can also try out this adjust brightness and random saturation. So let's get back to this notebook. We have your adjust brightness, and we run this, visualize. we have this error missing positional argument. So let's get back to this and understand how it's used. We check on adjust brightness, and there we go. We need to pass in a delta, so we have to pass in this delta. Now this delta should be in the range -1, 1, and as you could see, when you add this delta, it basically just adds up to each and every pixel we have. So this 1 turns to 1.1, this 11 turns to 11.1, and so on and so forth. And we told you that this delta is a scalar and it's an amount to add to the pixel values. So let's go ahead and add this delta. Let's have that. We add the delta, and we have 0.1. So we run that again, and it should be fine. Okay, so that's fine. We now visualize, and that's what we get. You'll notice that there's some difference with this. Like this one appears brighter than this. And let's go ahead and increase this. Let's take 0.8 and then have that. Okay, so you see we are able to modify this brightness. We could also include the random saturation, and we have the original image. Let's get back to documentation for random saturation and see what we need to pass in. So there we go. We have this image. We pass in the lower and the upper limit. So here, let's find this lower upper limit. We are told here we're gonna get an error if the upper is less than the lower, which is logical. Lower should be less than the upper, and then if the lower is less than 0, so we have to ensure that we're dealing with values greater than or equal to 0. So getting back here, we have saturation, that, and then we have lower, let's say 2, and then upper, let's say 12. Take this off, run again, and visualize. Okay, so that's fine. So you see we've added some random saturation, and this is what we get. We could obviously reduce this. We could make this fall in the range 0, 1, and here is what we get. Okay, we now check out on cropping. Let's check out this central crop. Here we have central crop, and the original image. So that's what we have. Let's make sure we understand exactly how it's meant to be used. So here we have this, and then there's this central fraction. So here they'll explain how this works. Now, where x is the central 50% of the image, it is a float which lies between 0 and 1. As you could see here, 0.5 has been picked, meaning that we're gonna pick 50% of the image, but this portion of the image we're gonna pick has to be centralized, that has to be surrounding the center. So that said, we've understood how that works. We can now put that, let's say 0.3, run that and see what we get. Okay, so you see we get this portion right here. Now what if we expand this to, like, say 0.8? We expect to have some black regions now. We run that, and you see we have some black regions. So it's actually centralized. Let's take this off. You see it's actually centralized, and the reason why we have something like this, it's actually cutting out like this and something like this. So this is what we get in here, something like this. Okay, so this is what we get when we do this central crop. Now the way we're gonna integrate this augmentation in our data pipeline is gonna be similar to the way we did with the resize rescale. So just like we use this map method, we are gonna reuse this same method for our augmentation. Here, let's suppose let's add this code and then define our augment method. So we have this, let's put this down, and okay, so here let's just have your augment. We have this augment method, image, label, and then what we'll do is we'll take the image, and then for that image we're gonna have the rotate 90 degrees of that image. Then next we are gonna have adjust saturation, and then pass in the image and specify the saturation factor. So here we have our saturation factor equal, say, 0.3. Now you could always feel free to visualize this so you don't get to poorly augment your data. That said, here we could have this saturate. Oh, we didn't copy that. Anyway, this flip left right. Let's come back to this. We have this adjust saturation. We could check that out, and let's have it here. Okay, we have that. So we run this and visualize to see exactly what it's going to look like. We modify that image to original image and then run it again. Okay, so this is what we get. Now that's fine. We could also include the flip left right. So here we have image, tf.image, flip left right, and then what we do is we could return the image and the label. So that's fine. Then we could also just simply include this resize rescale in this augment. So here we have image and the label equal resize rescale, which takes in the image and the label. So we resize and rescale before doing the augmentation. So that's it. Now we have this augment method defined. We could now, instead of doing this here, so here we have augment. Now another thing we want to do before doing the map is actually shuffling. So we'll modify the order in which we're doing things. Now here we have this train data set. We could have that, and then we have the train data set right here. Dot shuffle, dot batch, and dot prefetch. So yeah, that's what we have, and then we just include the mapping right here. So instead of doing the mapping before the shuffling, we just do it after the shuffling. And there we go. Let's now have this. It's basically this with augment. So we just have that, and then there we go. We have this map. Okay, so we now have that for the training, and then we could close this up. So that's fine. We repeat the same process for the validation and the testing. So yeah, we're gonna modify it just as we did with the training. We have here our validation. Then we include this map right here, map, resize, rescale. Now notice how we are not augmenting the validation and test data sets. So here we have the validation, and then we now do the same for the testing. Anyway, for the testing, we only used the map. That is, we only did the resize rescale. So that's fine. We will now take this off. Train validation, that's off. That's fine. Okay, so here we have our test data, we have our train data, and then we have our validation data. At this point, everything is set up. We could now rerun ourselves. So we start out with training. So that's fine. We'll come back, get back to this. We have our data. We will run all the cells, and our model created. So yeah, we're gonna work only with this sequential API and skip out all this other methods of creating models. Once we're done with that, we get right up to this level. Okay, so now we get into training. That's fine. I'll compile the model, and we wouldn't use any callbacks for now. Take that off and start training. We're now done with training, and we'll see the results right here. So as you could see, the model performs very poorly, and we'll try to understand why the model doesn't perform as well as it performed without the data augmentation. Now, if you can recall, what we did for the data augmentation was that we rotated the image by 90 degrees anti-clockwise. We adjusted the image's saturation, and then we flipped the image left right. But taking a look at the kind of data set we're dealing with, this saturation shouldn't be a great idea. And this is simply because if we look at each and every one of this, What differentiates a parasitized cell like this one and this uninfected cell is this patches we have right here. So you'll notice that with a parasitized cell, we generally have this kinds of patches, whereas with an uninfected cell, we practically have no patch. And with this, whereas here you could see these patches. And so rotating or flipping left right wouldn't change much about that. So that is acceptable. Now the problem with modifying the contrast is when you modify the contrast, you tend to make the parasitized cells and uninfected cells less differentiable. And so it isn't a good idea in this case to modify the contrast or saturation of the image. Let's take this example so we could clearly understand why this saturation data augmentation strategy isn't a good idea. So yeah, right here, what we'll do is we'll just copy out this and then paste here. We'll take out just two elements from our data set, and then here we have this 1, 4, and 2i plus 1, and we have the im show. From here we create another subplot. There we go. We have that, and this one now is a saturation. So tf.image dot adjust saturation. That's it. And then we'll pass in the image, and that's what we have. So here we have this first subplot and this other subplot. We have that too. Now we could run this and see what we get. Missing the positional argument. That is the 0.3, the saturation rate. So here we have 0.3. We're using exactly what we used previously. So here we have that, and this is what we have. In this example, we have both in uninfected cells, so we wouldn't actually see much difference. It's true this is modified, this too is modified, but there isn't much difference. Let's take a parasitized cell. Let's rerun this again. Hopefully we get a parasitized cell. Okay, as you could see here, let's take this off. As you could see in this parasitized cell, what could clearly show the model that this is a parasitized cell is this patch we have right here. But when we adjust the saturation, it turns into this. And you'll notice that this parasitized cell now looks more like an uninfected cell. So the model isn't able to differentiate between these two clearly. So we see clearly that using the adjust saturation data augmentation strategy isn't a great idea. Let's comment this part, and that's fine. Now we're going to modify our strategy. So just right here, what we had previously, we're going to take this off. So we comment this, and then we'll retrain our model. And so here we retrain our model after modifying our data augmentation strategy. We run this again, and after training, as you could see, we get these results. Now we check out this loss. This is what we get for the loss, and if we look at the accuracy, we see that it looks more like what we had previously, though we still have that maximum validation accuracy of about 94% and the train accuracy of about 99% right here. And though the data augmentation strategy hasn't closed this gap we had between the training and validation accuracy, we'll see in other sections how data augmentation will be very instrumental in helping reduce this gap between the training and the validation scores. So far, we've been applying data augmentation by using the image methods. Now, the other way we could apply data augmentation is by directly making use of keras.layers. So you come right here, tf.keras.layers, as you could see, and then you'd notice that among those layers we have these layers which permit us do modifications on images, like with this random contrast, which permits us randomly adjust contrast during training. Here we have the definition of this layer, this random contrast layer, and we have this attributes right here. Now, apart from this random contrast, we have the random crop, we have the random flip, and you could always get all these definitions get back to, yeah, let's have this flip. Now the mode horizontal and vertical, so we're gonna flip it both horizontally and vertically. We could also have other modes like horizontal, that's kind of a left right flip. We have vertical, kind of up down flip. We have horizontal and vertical, which is a mixture of the two, and the default is horizontal vertical, as we've just seen right here. We also have this random rotation, which you could see, random translation, random zoom, so you could randomly zoom the data you're training on. And you also have this resizing. So we had looked at resizing previously, but not actually on the data augmentation. So we did the resize using Tf.image. Now you could also do this resizing via this resizing layer. Now here you have the height and the width as we had, similarly to what we had in the image. We could scroll down and check on others. We don't really find anyone here. We could scroll back up, and that's it. Anyway, what's important to note is that you could create or you could implement data augmentation via two main ways, using the Tf.image and using the keras layers. Now, we are going to look at how to re-implement this data augmentation strategy we had previously via the keras layers. So here we had this rotation. So we had rotation and we had the flip left right. So we get back to documentation, and then what do we have here? We have this random flip right here, and then we're going to select the mode to horizontal since we're doing left right flip. So we'll copy this out. We have that layer, random flip. Let's put this just below. So this is the augmentation. This is augmentation using Tf.image. So Tf.image augment, and then this is augmentation using keras layers. So tf.keras.layers augment. Okay, so here we have our augment. It takes the image and the label. But since we actually build in keras layers, we are not gonna take this way. We're gonna have augment layers. It's just a way of differentiating between these two, augment and augment layers, which is a sequential model. So we have the sequential. We're gonna make use of the sequential API, tf.keras.sequential, and then just right in here, we are gonna specify all these different steps. And so we copied this out from the documentation. Let's just space it out here. We have this random flip. So we're gonna use this random flip right here. Let's take this. Let's import random flip from the layers. So we have your keras layers. There we go. We'll import random flip. Now we could have this. We have random flip. Okay, so we have the random flip imported, and then the other one is that rotation. Let's get back, and we have here rotation. Let's check on that. We have, let's scroll up and let's just do a quick search. So here we have rotation. Okay, so here we have random rotation, and don't forget we rotate in 90 degrees in the anti-clockwise direction. So here we have to be careful to make sure we re-implement that same kind of rotation we had seen before. Now here we have this definition. We have a factor, fill mode, reflect, interpolation, bilinear, the seed for reproducibility, fill value, and that's it. Now let's check down here and understand better this factor. Now this factor we have here is actually this tuple, and this tuple is going to represent our range. To better understand this range, you should note that it's like each and every one of this represents a fraction of 2 pi. Now what is pi? Pi equals 180 degrees, so 2 pi is 360 degrees. So we're looking for a fraction of 360 degrees. Now recall that we're going anti-clockwise by 90 degrees. Like we're just trying to redo the exact same thing we have with the Tf.image. So here we're gonna look for a way to get 90 degrees from this 360, and to do that we need to divide this by 4. In other words, it means we're gonna get 25% of this 360, and 25% of 360 is 90 degrees. So 90 degrees, not percent. So that said, we want to get 25%, and that's fine. Now from what is given to us here, this is we present as a single float. This value is used for both the upper and the lower bound. For instance, this results in an output rotation by a random amount in this range. A positive value means rotating counterclockwise, while a negative means rotating clockwise. Now we're interested in rotating counterclockwise as anti-clockwise. We're actually interested in rotating this way. Recall it was this is clockwise, so we're not interested in this, we're interested in this anti-clockwise 90 degrees rotation. So we'll take positive values, and then we'll try to ensure that it lies in that given range. Now, given that we are actually picking just random numbers, and unlike the root 90 method we have seen, which was somehow fixed, what we'll do is we could just pick a range between, say, 90 degrees and say 90.1 degrees, or any value very close to 90. So that said, recall is going to be positive, unlike if it was clockwise, it will be negative. So here we're going to pick the 0.25 because we want to get 25% of this 360. So we have 0.25, that's positive 0.25, up to say 0.2, let's say 501. So let's pick out this range. So we'll work in this range so that we'll be around this 90 degree that we're actually looking for. Now that said, since we're taking 0.25, 0.205 or 201, what we'll have here is 25% of 2 pi, which is 90 degrees. So it's going to be translating it to 90 degrees and a value very close to 90 degrees. So it will be like 90 point a value very close, or 0.00 whatever degrees. So it's going to be around this. So we pick this up, and that's fine. Now we are sure it's anti-clockwise because we've picked it to be positive. Now the fill mode and the fill values will just be the default values, even the interpolation too. So that said, we get back to the code. Let's copy this out right here, random rotation, copy this out, get back to the code. Let's include random rotation here. So we have random rotation. Okay, random rotation, that's fine. We could now run this. Let's run this cell and then get back to our method, or this layer we're trying to construct right here. So here we have the random flip and then the random rotation. Now we started in this other method with the rotation, so here we're going to redo that. Now we have this random rotation, okay, and then we have this factor. So we just do exactly what we just agreed to put. So we have the factor, a tuple, take 0.25 and 0.2501. Okay, now we have that. We just, for the rest, we take the default value, so we don't need to put those values. So that's fine. We've done with this first layer. The next layer will be this random flip. So we just put out this random flip. Let's copy this, copy that, and then paste it out here. Now we have our random flip. We've decided on the mode, take that off, and that's fine. Now this is horizontal, so let's have this as horizontal. Okay, so we have this random flip and that, and there we go. We have our layer, our sequential layer. Okay, now let's take this off, and that's fine. So we have this augmented layers, or this augment layers, which we run this time around. Horizontal is not defined. Now let's use the small case horizontal and run again. Horizontal still not defined. Let's pass this as a string. Horizontal, run again. Then we could redefine an augment method. Let's call this method augment layer, and then this takes in the image layer, labels. And then what we'll do is we're gonna return this augment layers, which we just created, and then pass in the image, specify that training is equal true. That's okay, and then we send out the labels. So here we're gonna take this augment layers, we're gonna take the image and pass into this layer right here. It's gonna rotate the image and then into this other layer, which is gonna flip that image. So we get our output, which has been augmented, and we have our labels. We run this, and then we get to this here where we have our augment and we have augment layer. So we call the augment layer method right here. We call this method, that's fine. We run that and everything is okay. Now after running this training, we have this error. So it shows that we have an error at the level of the shapes. Now let's get back. The problem here is we forgot to do this resizing before the data augmentation. So we could copy this out and then put out this resizing here. We have the image and labels, label, let's say image and label, we have that. And then we resize and rescale. After resizing and rescaling, we now do the augmentation. So we run this again, and then we run this training. As you can see, all is well. We will now look at another way of creating or of doing data augmentation. Before doing that, we should also note that instead of doing this resize rescale using the Tf.image as we had done here, that is using this Tf.image resize and then by dividing by 255 as we just did, we could also use the resizing and rescaling layers. So right here, we're gonna include those layers. Here we have resizing and then rescale. We run that, and then just here we're gonna include that resize rescale. So here we say resize rescale layers. Okay, so now we have this our sequential API, and then here we start with resizing. So we have the resizing, take this off and have this. Here we're gonna put im size. We have im size. Okay, and then we do the rescaling. So we have rescaling, take this off, and we do the rescaling. So here we have this taken off, 1 divided by 255. Okay, so now we have those layers which are responsible for resizing and rescaling. Resizing and rescaling. So we'll see how we'll replace this method in doing the resize rescale. So that's it. Let's get back to this augment. We had augment layer right here. After getting this image, we do resize, rescale, and layer. So we do the resize rescale on the image before doing the augmentation. Let's take this off now, and this should be fine. Now, since we've built this resize rescale layers, we could replace this here, resize rescale layers, even for the test set. And then we do same for this. This already fine. Augment layer is what we've seen already. For the validation, we have resize rescale layers. Okay, so that's fine. We run this, run the validation, run the train, and that's fine. We then train our model and see what we get. So that's it. Our model is training. Everything is working well. Now let's pause this and then check out this other interesting way of doing this data augmentation. So as of now, we've seen how to do data augmentation by using Tf.image and then by building these layers. Now we'll see the importance of building these layers. But before looking at this importance, it's important to note this, and that is the fact that when you're working with a Tf.image, you have more flexibility. As with these layers, you are kind of like restrained to what you could do with data augmentation. Though these layers already have many common data augmentation strategies like the rotation, the zoom, the crop, the flipping, and the others. Nonetheless, when you're working with a Tf.image, you'll see that you have many more operations you could do. Like if you open up this Tf.image right here, you see you have many more methods and you could do many more stuff with this. Anyway, getting back to our code, we have to note that the advantage of these layers is that you could embed this into the model itself. Now let's explain. Supposing you have, let's take this off. Supposing you have your training pipeline here. So you have that TF data, you do the shuffling, you do the mapping, you do prefetching, caching, and everything you need to do. like with your training data. So yeah, you're dealing with your data. And then next, after doing all this resizing, rescaling and everything, you now pass this into your model. So you pass this into your model, and then you train your model and have all your results. Now when you want to test this model, you will actually still need to do resizing and rescaling. So you still need to ensure that you resize your image, and then you also ensure that you rescale your image before passing to the model. Now if you could recall, like let's go down, let's get down here. You would see under the testing section, let's look at this, under the testing section, that we made use of this test data. And this test data, as we have seen from here, was already resized and rescaled. So if you check here, you see we had done some resizing and rescaling right here. Now what if you have to take this your model which you've trained into another setup, and obviously in that new setup you will still need to resize and rescale, because just like here, before testing your model, you had to resize and rescale. So what if we input this resizing and rescaling in the model? So if we embed this resizing and rescaling in the model, it means that no matter where we go with this model, we don't need to resize and rescale. All we need to do now, we'll take this off, or rather we'll take this and put in the model. So all we need to do now is just to pass in your data without the resizing or rescaling, and the job is done. So now we're gonna see how to do this with this augment, or rather with the resize rescale layers which we've just seen. We also do with the augment, but the augment isn't very useful since in testing time we don't make use of the augment. What's more important here to note is the resizing and rescaling. Although if you can include this augment layers into your model, it makes the training faster. Anyways, let's go ahead and see how this is done. So firstly, you have the layers which you've built. You've had the augment layers, and then you've had the resize rescale layers which we have had here. So all we need to do is to get to this model right here, and then after the input layer, you just have the resize rescale layers, and that's it. And then you have augment layers. So here you have resize rescale layers and augment layers, and that's all. So with this, you don't need to do any resizing or rescaling on your input, because this is going to be done, or this are layers which are now part of your model. And then here too, you don't really need to specify this image size. You could now have this as known, and then yeah, you have that. So you could put in any image, and then the resizing and rescaling will be done in that model, such that you could put this model or use this model in any environment, and all you need to do is to pass in the image, and you have your corresponding output. Now we've modified this model, we need to also modify the way we working with our testing and training and validation data sets. So let's get back to this right here. We have the down here, we have this augment, and then we have this test data set. So with the test data set now, we do not need to do this again. So we just comment this because we don't need to resize and rescale anymore. Now with the validation, you see with the validation, we do not need to do this mapping anymore. You see, we take this off. We don't need to do this resizing and rescaling. And then with the training, we get back to the training. This training, we do not need to do this augment because we've included this already. So all we need to do now is just to shuffle, put this in batches, and do the profession. So that's it. So we have this. Okay, we will now rerun this and see how the training goes. We run this training. As you can see, we have this very long trace, and with all this, with this message right here, which isn't very readable. So what we could do is, generally when you're trying to get or understand an error and you don't seem to have an idea of what's going on, you could run the model eagerly. So we use the eager mode. So run eagerly equal true. And here you see when we run this again, you would have a shorter error message or more readable error message. So you check this out and you see you just have this shorter error message. It should be noted that TensorFlow operates in two main modes. That is the graph mode and the eager mode. So as you could see here, when you don't specify this, you run into training in the graph mode. The graph mode is actually a faster and more efficient way of training our model, whereas the eager mode is slower but more easily debuggable. So when you have errors like this, you're advised to run in this eager mode, and when everything is okay, you could take this off or set this simply to false. But by default, it's not true. So by default, we are not in eager mode while doing this training. Now that said, let's scroll down and check on our error. And what it reads is we cannot batch tensors with different shapes in component 0. First element had this shape and the element 1 had this other shape. So we understand from this that since we doing the rescaling in the model that is in here, we're actually doing the rescaling, the resizing and rescaling in here. We have this batching. That's what we had here. We had doing this batching on elements which do not have exactly the same shape. And so to avoid this, we'll just fix this batch size to be equal 1. So we'll work with batches of 1, and work with batches of 1. We run that and we run our model again. We run this and that's fine. So you'll notice that the training starts and everything now works well. Though it's gonna be slower since we're no more working with batches of 32 but now batches of 1. And also to ensure that this goes even faster, let's take this off. So let's pause this and then let's restart training with the graph mode. So we run this, and this should now be faster than what we had previously. Now training is going on. We could pause with the training and see how it's going to be very easy now with this model to run inference. To test this, we've had this cell here, the cell image, which we'll run inference on. So we have the cell image, and then we'll make use of OpenCV to read this image. So here we have our image equal CV2 imread this image. So and yeah, you could start by printing out image. So you would have that not defined. Let's import CV2 right here. Okay, so we go ahead and import CV2. We can close this and we could import that just here. So we import CV2, that's OpenCV. We run that, and then we now rerun this cell. OpenCV actually stands for Open Computer Vision. So this is a very popular image processing library, which normally you cannot do image processing or open or computer vision today without really working with this. So that's how with OpenCV you could read an image. So it's image read, and then here we go. We have the, let's print out the shape so you see that it matches up with what we expect. We have that. Okay, so here's the shape of our image, and now we are ready to, let's add a batch. So here we're gonna have image equal tf.expand dems, and then we have the image, and then we specify the 0th axis. So we want to add the batch dimension, and then we print out this image. So here we have our image. Okay, that's fine. Let's print out the shape. So we should see that. Okay, we have this here, and now you see that we're gonna pass this into our model directly. So here we're just gonna do Lunet model dot predict image, and that's it. So all you need to do is just do this. We don't need to divide by 255. We don't need to resize, and the model is gonna understand. Now note that we are passing this image or this input, which is 265 by 262 by 3, and our model is gonna automatically resize this because we've included resizing in the model. So let's run this now and see what we get, and that's fine. So it tells us that 0, that is, it's parasitic, but which is actually wrong, but this is normal because we have not really trained the model for a long period of time. And clearly from here our results show that we should expect very poor results. Why is this disturbing? Let's scroll down. Okay, so let's scroll this way and then scroll back up. Okay, so you see that here we have this poor accuracy, 48%. If we train for longer, we could get to the 99% which we had already. So but this is actually done to show how easy it's gonna be for you to run inference on this model anytime you want to, in any environment you find yourself. So far we've seen two methods of implementing data augmentation with TensorFlow. We've seen the Tf.image and then we've seen the Tf.keras. Now with the Tf.keras, it's actually interesting when you want your pre-processing, that is, say, resizing, rescaling, and data augmentation to be in the form of layers. And with the Tf.image, it's more flexible to work with. Now we're going to look at a way in which we could build a custom keras layer based on the Tf.image operations. So recall that when we're working with a Tf.image, we had this rot 90 degrees, which was right here. And when we wanted to work with these layers, we had to play around with this to give us that same rot 90 degrees effect. Now what we'll do is, in order to create a layer which takes to create this rot 90 degrees keras layer and not just use this random rotation, because it's not exactly this, we are going to define a class which inherits from keras layers. So right here we have this class which we'll call rot 90. Let's call that rot 90, and then it inherits from layer. We have our init, there we go, self, super, there we go, dot init, and that's fine. So yeah, we have this rot 90 which inherits from layer, and then we'll define the call method. So we'll define the operation which is going to be carried out in this rot 90 layer which we're about to create. Here we have self, and then we have the input image. So what we simply want to do here is we want to have, or want to return the tf.image, the rot 90. So we're carrying out the same operation, but now we converted this into a layer. So here we take that, and then we have image. So that's what we output now. And that sounds fine. So here we've had this rot 90 which we've created. We run this, and then instead of this random rotation, we are gonna use this rot 90. So here we have rot 90. Take this off, nothing is passed, and that's it. So that's it. We have our rot 90 now, and we are no longer using the random rotation layer. So that's it. We get back and then run the cells and get to training. And as you can see, everything just works fine, and we've seen how to get the best of both worlds. As now we have the flexibility of Tf.image and the speed and portability of keras layers. Thank you for getting up to this point, and see you next time.